Hello and welcome to this video. Today I want to talk more about conditions and especially about conditional operators. As you remember, last time I showed you if, else and else if statements, and I explained to you that they are working with conditions, and if the condition is true, the code block below the if statement will be executed. Today I want to go into more detail about conditions and conditional operators, and to do that, let's start by taking a look again at how a condition is written. Okay, so condition is comparing two values with each other. Between these two values, you write the conditional operator that determines how these two values are being compared. The result of a condition will be either true or false, so it's a Boolean value. In your conditions, you can compare two values, two variables, or you can even compare one value with one variable. It is also possible to compare the result value of a method that you have called. You can just write the method call inside the condition, and the resulting value of this method call will be compared with the other value. Let's kick this lesson off with some examples. Let's create three variables. One integer that is called a with the value 5, one integer with the value 10 that is called b, and one floating point variable with the name c that has the value 5 as well. I will also create a method that will return the integer value 6. So let's start with our first comparison operator. The first comparison operator that I want to show you is equals equals, and it will compare two values and check if both of the values are exactly equal. The second equality operator is exclamation mark equals, and that's actually the opposite of equals equals because it will check if the two values are not equal to each other. To check this out, let's write an example for this. Let's write an example that is checking if a and b are not equals to each other. And let's write an example if a and 5 are equals to each other. Both of these examples should return true. And then I also want to show you a third example, and that is the comparison of a and c. Let's check if a is equals to c. And this is different because a is an integer value and c is a floating point value, so it's different from the comparisons above. If we run this, you can see that all of the comparisons are resulting in the Boolean value true. But why is that the case for the floating point and integer comparison? The answer to this is actually pretty simple. The compiler will convert the integer value to a float value as well and will then compare the two values. That means in C# you can directly compare floating point values with integer values. But careful, in most cases this is not good, and I want to explain you now why you shouldn't do that in most of the cases. These problems occur because of the floating point value and not because of the integer value. Actually, it's also problematic sometimes to compare floating point values with each other, and that is due to the fact how you save a floating point value inside a computer. For example, you know that everything inside your computer is saved as zeros and ones, so it's saved in binary. A bit is either 0 or 1. And inside the computer, if you save, for example, a floating point value after the 32-bit IEEE standard, it will be saved as 32 bits. The first bit will be the sign, so either it's positive or it's negative. Then you have 8 bits for the exponent, and then you have the rest for the mantissa or the fraction, I think you say in English. But the problem is that you have an infinite amount of floating point numbers, but only a finite amount of space where you can save these numbers. And that means you have only a finite amount of numbers that you can save, but you have an infinite amount of floating point numbers, even between two integer numbers, so two whole numbers. For example, if you have 1 and 2, the amount of floating point numbers between 1 and 2 is still infinite. That's the problem. And that's what's leading us to the machine epsilon, where epsilon is defined as the difference between two floating point numbers that come after each other and are representable with our IEEE 32-bit floating point number data type. That means all floating point numbers between your two representable values that come after each other, all values between those two representable values, will not be able to be saved inside your variable. So all these values will just be rounded down to the nearest representable floating point value. And also some of the numbers that terminate in decimal don't terminate in binary. And those two reasons are leading to rounding errors. And because of these rounding errors, it's sometimes hard to compare integers with floats or even compare floats with other floats. And that's why I would say if you start with inaccurate values anyways, I would recommend to use float or double. But if you start with naturally exact decimals and want to keep the accuracy because it's important for this case, I would recommend to use the data type decimal. This is because in the background, decimal is completely different in form of savings and in form of calculations if you compare it to double or float. Okay, but enough from this topic. I don't want to go into too much detail here. I just want you to get the basic case. And now I want to talk about the comparison operators that compare values. We have 4 of these operators. Let's start with the greater than operator. This one returns true if the left-hand operand is greater than its right-hand operand. Then we have also the opposite. We have the less than operator that returns true if the value on the left side is less than the value on the right side of the operator. And then for the last 2 of this type, they are exactly the same, but they are checking if it's greater than or equals, and the other one is checking if it's less than or equals. Let's do some examples with these. So let's compare if A is greater than B, which is false because A is less than B. Let's now compare if A is less than B, which is true because A, like I said before, is 5 and B is 10, so A is less than B. And now let's compare one more time if A is greater or equals to 5. And if we run this, you can see that the last case is true as well, because greater or equals means it can also be equals, like I said before, and 5 equals 5, so that is true as well. Now let's take a look at the Boolean logical operators. With those operators, you can combine 2 conditions or the results of 2 conditions. That means you can directly compare 2 complete conditions, or you can compare 2 Boolean values, or 1 Boolean value with 1 condition. The first logical operator that I want to show you is AND. If you combine 2 conditions with AND, the end result is only true if both of these conditions are true. If one of these conditions is false, then the end result will be false. Okay, so let's check this with an example. Let's add another condition here that is saying 5 is equals to 5. Now I will put both of these conditions in round brackets, and between both of these conditions I will put the logical AND operator, which is just an AND sign. And if we run this, you can see the result is true. In case you just need one of your conditions to be true, it's good if both are true, but you just need one to be true, then you can use the logical OR operator. To do that, just write a pipe between those conditions. And now, if we run the example again, you can see it's true again, because both of these conditions are true, but it would also be true if only one of these conditions would return true. So the end result is true if one of these is true, or even if both are true. In the most cases, you should use the 2 operators that I'm about to show you now. These 2 operators are basically exactly the same like the ones that I showed you before, but they have one slight difference, and that is why you should use them instead of the ones that I showed you before. Let's start with the operator that you write with 2 AND signs. So the one that you write with 2 AND signs is also comparing if the condition on the left side is true and the condition on the right side is true. And only if both of the conditions are true, the end result will be true. But the difference is, if the one on the left side is already false, it will not check the one on the right side as well. And this will save you some time, and it will also increase your performance a bit. And this is also the case for the 2 pipes. If you write 2 pipes for the OR operator, it will check the first condition, and if the first condition is already true, it will not check the second condition anymore, because it doesn't matter for the outcome. So let's check this by adding a debug log to our method call that we have written earlier. And let's compare if the method call is equals to 5, which is not true because the method call returns 6 and therefore it's not equals to 5. But as we know, this doesn't matter because for the OR condition, it only needs one condition to be true for the end result to be true. And also we wrote 2 pipes, and that means it will only check the first condition first. And this one is already true, so it will not check the second condition anymore, and that means the method will not even be executed. And if we check this now in the console, you can see that the debug log from our method was not executed. That is because the second condition was not even checked, and also the method in the second condition was not executed because the first condition was already true, so it stopped there and didn't even bother to check the second condition. The next logical operator I want to show you is the XOR operator. It is called XOR for exclusive OR. It will check if exactly one of the conditions is true. If both of the conditions are true, the end result will be false. If both of the conditions are false, the end result will be false as well. And only if one of the conditions is true, then the end result will be true. So if you want to use the XOR operator to check if exactly one of your conditions is true, so only exactly one of your conditions is true, then you need to use the circumflex symbol, because this is the XOR operator. And the last logical operator that I want to show you is the negation operator. The negation operator will perform a logical negation. That means you will get exactly the opposite of the Boolean value that you have right now. So for example, if you have true and you use the negation, then you have false. And if you have false before and use the negation, then you have true afterwards. To use the negation operator, add some extra round brackets around your condition, and before the round brackets, write an exclamation mark. Okay, let's try the XOR operator out first. So let's write an XOR here and see what happens. And as you can see, like this, it is true because exactly one of the two conditions was true. And now, let's try the whole thing with the negation operator. So let's add some extra round brackets and add the negation operator. And as you can see, now this whole thing will result in false because it was true before. Okay, now I also want to mention that there can also be functions that may be used for specific conditions. For example, a class that saves key value pairs may have a method that is called hasKey and will return true if the key is already saved in there, and false if it's not saved in there, of course. Okay, another thing that is frequently used and that I especially love to use for assigning values, instead of using if-else, if I have some logic that is assigned to my values. For example, if I have a condition and if it is true, I want to assign the one value, and if it's false, I want to assign another value. I like to use this shorthand for that. Okay, let me show you that with an example. Let's start by creating a variable called d of type integer, and let's write an equal sign to assign a value to it. Let's start by writing an opening round bracket. Then we write our condition. In this case, we write a equals to 5. And then we close the round bracket, so our condition is over. Then we will write a question mark followed by the first value. And this first value will be put into the variable if the condition is true. Then we will write a colon followed by the value that shall be put into this variable if the condition was false. And then we will just write the semicolon like always. Okay, and for the last bit of this video, I want to talk a little bit about null again. Like I already mentioned before, null means that the reference type variable doesn't refer to any object. Also, null is the standard value for a reference type variable. And data types that are normal data types are not allowed to be null, except you make one of them nullable. You can do that by writing a question mark behind the data type. For example, if we create a variable called e and write int question mark and then e equals null, that is completely fine because now this variable e is nullable. So what we can do now, for example, and that is also the reason why I wanted to show you this in the conditions video, we can now, for example, say that the variable a will get the value of our variable e, but only if the variable e is not null. And to do that, we will just write two question marks. And now we need to offer an alternative for the value inside e, because if e is null, it can't be put into a. So the alternative comes after the two question marks. For example, here we can say the alternative is 5. So let's go over this one more time so nobody is confused. So this what I wrote here means that a will now get the value that is saved inside e, but only if it's not null. If e is null, then a will get the value 5. Okay, now to show you that, let's debug log the value inside a again. And now let's start the script. And if we start the script, you can see that the value 5 will be printed to the console. And that is because e was null, so the value 5 was put inside A. Welcome to the end of this video. Hit the subscribe button to stay updated. Also, if you need some high quality assets for your game or like our channel and want to support us, feel free to check out our assets at the Unity or Unreal Asset Store. You'll find the link to our store pages in the description. I hope you learned something new and see you next time.